In this video, I would like to discuss chemical equations. Now, chemical equations are fundamental to chemistry. Chemical changes are shown using chemical equations, and this allows us to show what is happening in a chemical reaction. One way we can show a chemical reaction is to write a word equation. Let's take an example. Here we have methane, and that burns in oxygen, giving us carbon dioxide and water. Now, the molecules on the left-hand side of the equation, methane and oxygen, are known as reactants because they react with each other. The molecules on the right-hand side of the equation, carbon dioxide and water, are known as products because they have been produced from the reactants. So the reactants react completely to form the products. Writing equations in word form is not as quick as writing in chemical form, and you can't tell straight away what happened to each of the atoms. However, it's an easy and clear way of showing the equation. But in most questions you will do, there is a need to write symbol equations. Chemical equations show atoms on both sides, and we can show this in shorthand form using symbol equations. Symbol equations show the symbols or formulas of the reactants and products. Let's look at an example. Here we have calcium plus oxygen gives us calcium oxide in word equation format. In symbol equation format, this looks like calcium reacts with oxygen to give calcium oxide. Notice I've put oxygen with a subscript of 2 rather than just O, because oxygen exists as a molecule made up of 2 atoms. So when including oxygen in a reaction, we have to put O2. In the equation, you will also see there's a 2 in front of the calcium and the calcium oxide. I'll explain why this is. When writing symbol equations, both sides of the equation must balance. What do I mean by balance? Well, there must always be the same number of atoms on both sides. Atoms can't disappear. An equation is balanced by putting numbers in front of the formulas where needed. Let's take an example of nitrogen reacting with hydrogen, giving us ammonia. So this can be written as N2 plus H2 gives us NH3. The formula is correct, however the numbers of some atoms do not match up, so the chemical equation is not balanced. Firstly, we check to see if there are equal numbers of atoms of each element on both sides. The reactants, which is the left-hand side, we have 2 nitrogens and 2 hydrogens, and the products, or the right-hand side of the chemical equation, we have 1 nitrogen and 3 hydrogen. So they are not equal numbers of atoms of each element on each side. The first rule of balancing equations is you can't change formulas by changing the little numbers, as this would change the type of chemicals in our equation. So we can't change N2 to N3, as N3 would be a different substance which is not nitrogen. We have to concentrate on changing the numbers in front, or the big numbers of the different elements and compounds. These represent how many of our substance there are. So, to increase the number of nitrogen molecules on the right, we would put a 2 in front of the NH3, meaning there are 2 nitrogen molecules, giving us 2 nitrogen atoms on the right hand side. However, we could technically put a half in front of the N2 on the left hand side, as we only need 1 nitrogen atom on the left hand side to match the right hand side. But this is not possible when balancing chemical equations. A rule for these big numbers is that it must be whole numbers. So let's balance out this chemical equation correctly. There are 2 nitrogen atoms on the left, but only 1 on the right. So let's put a big 2 in front of the NH3. This now gives us 2 nitrogens and 6 hydrogens on the right. Now let's concentrate on the hydrogens. There are 2 hydrogen atoms on the left, but 6 on the right. So let's put a big 3 in front of the H2, which gives us a total of 6 hydrogen atoms now on the left hand side. Let's see if there are equal numbers of each element on both sides. So we have 2 nitrogens on the left hand side and 6 hydrogens on the left hand side, and we also have 2 nitrogens on the right hand side and 6 hydrogens on the right hand side. So the equation is balanced. Here we can add state symbols if we're asked to do so, such as solid, liquid or gas. Let's try another example. Sulfuric acid plus sodium hydroxide gives us sodium sulfate plus water. Let's start by looking at what we have on the left. We have 3 hydrogens, 1 sulfur, 5 oxygens and 1 sodium. Now let's look on the right. We have 2 hydrogens, 5 oxygens, 1 sulfur and 2 sodiums. So the equation is not balanced. So let's focus on the least common elements first. So firstly we'll concentrate on sulfur. So on both sides there is 1 sulfur, so this is balanced. Now let's look at sodium. On the left hand side we have 1 sodium, and on the right hand side we have 2 sodiums. So we need 1 more on the left. So let's put a 2 in front of the sodium hydroxide to balance the sodiums on both sides. So now let's look at the hydrogens. We have 4 hydrogens on the left hand side and 2 hydrogens on the right. So we need an additional 2 hydrogens on the right. So let's put a 2 in front of the water to balance the hydrogens. Finally, the total number of oxygens on the left hand side is 6 and on the right hand side is 6. So we have balanced this equation. Let's do a final check. Here we have 4 hydrogens, 1 sulfur, 6 oxygens and 2 sodiums on the left hand side, and we have 4 hydrogens, 1 sulfur, 6 oxygens and 2 sodiums on the right hand side. So we are balanced. Let's try one final example. Let's balance the equation of iron plus chlorine gives iron chloride. So on the left hand side we have 1 iron and 2 chlorine, and on the right hand side we have 1 iron and 3 chlorines. So iron is balanced on both sides. However, there are 2 chlorines on the left hand side and 3 chlorines on the right hand side. So let's firstly start by putting a 3 in front of the chlorine on the left hand side, giving us a total of 6 chlorines. And now let's put a 2 in front of the iron chloride on the right hand side, which gives us 2 high ions and 6 chlorine on the right hand side. We now have to balance the iron, as we have 1 iron on the left hand side and 2 iron on the right hand side. So let's put a 2 in front of the iron on the left hand side and do a final check. We have 2 iron and 6 chlorines on the left hand side and 2 iron and 6 chlorines on the right hand side. So that's all for this video. Hope you found this useful. If you did, please give a like and subscribe, and I will see you in the next video.